Sushi that rivals top-tier restaurants ready in just minutes? Imagine machines crafting thousands of perfect rolls every hour, with rice of flawless consistency forming the base of nigiri. We're here to unveil the secrets behind automated systems that transform tons of raw ingredients into true culinary masterpieces. Curious about how sushi is made for supermarkets and restaurants? Stay tuned to find out. It all starts with rice. As the cornerstone of sushi, cooking it properly is one of the most crucial steps. In large sushi restaurants and production facilities, high-capacity rice cookers are used, capable of handling between 22 and 66 pounds of rice per cycle. These cookers ensure precise control over temperature and cooking time, producing rice with the perfect consistency every time. The second key ingredient is fish. In the United States, most sushi operations rely on frozen fish, especially salmon and tuna, to meet FDA requirements for parasite destruction. Rapid thawing systems maintain strict temperature control, preserving the fish's texture and flavor. These systems can defrost up to 1,000 pounds of fish per hour. Fish slicing machines are equally impressive in their efficiency. Some models can cut up to 1,000 pieces of fish per hour with remarkable precision. Automated blades adjust slice thickness, allowing for customization depending on whether the fish is destined for nigiri, rolls, or sashimi. Filleting machines also play a vital role, expertly processing fish to reduce waste and ensure uniform pieces. These machines can handle up to 200 fish per hour, significantly reducing prep time compared to manual labor. Vegetables like cucumber, avocado, daikon radish, and others require careful preparation. Modern vegetable washing machines can handle up to 660 pounds of produce per hour. These machines effectively remove soil and contaminants, ensuring sanitary conditions are maintained throughout the production process. Vegetable slicing machines allow for rapid cutting into thin strips, cubes, or slices. For instance, thin cucumber and avocado strips are essential for rolls. These machines can process up to 220 pounds of vegetables per hour, producing perfectly uniform pieces that contribute to sushi's consistent appearance. Once prepared, vegetables are stored in specialized refrigeration units with automatic humidity control to keep them fresh throughout the day. This is particularly important for avocado, which oxidizes quickly and can change color if not properly stored. Nori, or pressed seaweed, usually requires minimal preparation, but specific protocols help keep it fresh and crispy. Large sushi production facilities often use special low-humidity storage containers to prevent nori from becoming soggy before use. Some automated sushi-making systems even include machines that cut nori to the exact size needed for various types of sushi, streamlining the process further. Infrared and optical scanners are used to check the quality and freshness of ingredients. For example, these scanners can assess the freshness of fish by measuring moisture levels and the color of the flesh, helping to identify substandard products before they reach the production line. All ingredients are stored at optimal temperatures. For instance, fish is kept between 30 and 28 degrees Fahrenheit to maintain freshness. Automated refrigeration systems monitor and record temperature data in real time, ensuring consistent storage conditions. The automation of ingredient preparation significantly reduces the time needed to ready products for use. Thanks to these technologies, a large sushi restaurant or production facility can process up to 4,000 pounds of ingredients daily, guaranteeing both freshness and uniformity in every sushi portion. This not only cuts labor costs, but also improves sanitary conditions by minimizing direct human contact with food. Have you ever tried making sushi at home? I have. I bought the fish, cream cheese, even a special rolling mat. Watched a few YouTube videos, feeling pretty confident. After a few hours of trying to put that newfound knowledge into practice, the result? Let's just say it was very homemade. You know what that means. Delicious on the inside, but hilariously amateur on the outside. And don't forget the hours spent on it. What did I learn? Never again. I'll stick to ordering sushi delivery. It's my true love. Before cooking, rice needs to be thoroughly rinsed to remove excess starch, which can make it overly sticky. Industrial rice washing machines can process between 110 and 220 pounds of rice per hour. Some models allow for adjustments in the intensity and number of rinse cycles to achieve the perfect texture. Each rinse cycle takes about 3 to 5 minutes, which is significantly faster than manual washing. These machines also regulate water usage, helping to minimize waste. After washing, the rice moves to specialized industrial rice cookers, which automatically control the temperature and cooking time to ensure the ideal consistency. A single cooking cycle lasts between 45 minutes and 1 hour, depending on the rice volume and machine capacity. The cooker carefully manages the heating process, starting with cold water and gradually warming it, allowing the rice to cook evenly. Most rice cookers operate within a temperature range of 194 to 210 degrees Fahrenheit. Once cooking is complete, some models can keep the rice warm for several hours, ensuring it remains ready for use throughout the day without compromising quality. After cooking, the rice must be seasoned with a special mixture of rice vinegar, sugar, and salt, which gives it the distinctive flavor needed for sushi. On industrial kitchens, this step is also automated to ensure a consistent taste in every portion. There are specialized devices that automatically distribute rice vinegar, adjusting the amount based on the weight of the rice. For instance, approximately 17 ounces of vinegar are typically used for 22 pounds of rice. The rice is then mixed using specialized mixers that cool it and maintain the optimal temperature to prevent excessive clumping. The rice is usually cooled to around 100 degrees Fahrenheit, which is an ideal temperature for forming sushi. Once prepared, the rice is kept warm in specialized containers that automatically regulate the temperature to prevent it from spoiling too quickly. The sushi shaping stage is the final step in the production process. In large-scale American facilities that specialize in mass-producing sushi for supermarkets, restaurants, or delivery services, this process is highly automated. This automation ensures high productivity, consistent quality, and precise portioning, almost like modern-day samurai. The process begins with preparing the rice bases that serve as the foundation for nigiri, rolls, and maki sushi. Nigiri machines can automatically form rice balls of uniform weight and size, ensuring accuracy in every serving. For instance, automated nigiri machines can produce rice balls weighing 10 to 15 grams each, which is the ideal weight for easy consumption. Some of the latest models can produce up to 4,000 pieces of nigiri per hour. These machines guarantee uniform shapes, reducing the risk of sushi falling apart during serving or packaging. Additionally, they provide perfect rice compression, ensuring that each piece has a consistent density. For various types of rolls, such as futomaki, uramaki, and hosomaki, specialized machines are used to automate the rolling process. These machines distribute rice evenly over a sheet of nori, apply the filling, and then roll it all together. The system is calibrated to ensure the rice covers the nori evenly, with a thickness of about 5 to 8 millimeters, depending on the type of roll. The machines can also automatically add fillings to the center of the roll, precisely controlling both the quantity and placement. The amount of fish, vegetables, or avocado can be adjusted to within a gram for each serving. Once the roll is formed, cutting machines take over. These machines are equipped with ultra-sharp blades that slice the roll into 6 to 8 pieces without squashing or deforming it. The system adjusts the thickness of each slice to ensure uniform height, typically around 1 inch per piece. Some machines even feature a self-cleaning function for the blades after each roll, preventing rice buildup and ensuring a perfect cut every time. Now, that's the kind of knife I'd love to have at home. Coca-Cola's annual sales exceed $47 billion, which translates to more than 1.9 billion bottles consumed every day. To meet this huge demand, the company operates over 900 bottling plants worldwide. But how exactly is this refreshing, fizzy drink made? To uncover the secret ingredient added to Coca-Cola, we will embark on a journey across the United States and dive into the atmosphere of one of Coca-Cola's massive production facilities in the country. The mysterious formula that defines Coca-Cola's flavor is carefully kept secret. Some say it is stored in one of the most secure vaults on the planet, and only a select few have access to this culinary secret. However, it is known that the drink contains a blend of natural flavors, including vanilla, cinnamon, and citrus. This precise combination of aromas gives Coca-Cola its signature taste, setting it apart from other sodas. The production of Coca-Cola is a detailed and complex process that ensures consistency and perfection in every bottle of this iconic drink. At the beginning of the process, the components are combined. A precise mixture of high fructose corn syrup, caramel coloring, caffeine, and phosphoric acid is blended in exact proportions to create a syrup with 50% sugar content. The syrup is then poured into massive mixing tanks, holding 5,000 gallons, where it is combined with water at a ratio of 1:5. At this stage, the mixture is continuously stirred to ensure the perfect integration of all ingredients. The next stage of the process is carbonation, where carbon dioxide is added to the mixture to create Coca-Cola's signature bubbles. This process is carefully controlled to ensure the same level of carbonation at all production facilities. To achieve this, the water is chilled to just above freezing, and carbon dioxide is pumped in under high pressure, allowing it to dissolve more quickly. Once the liquid has absorbed enough carbon dioxide, it is bottled and sealed tightly. When you pop open a fizzy Coca-Cola, the carbon dioxide under pressure is released, forming bubbles and creating the iconic fizz. Next, we enter the section dedicated to packaging the product. Here, plastic bottles are formed by blowing preforms into their final shape, before being filled with the carbonated mixture. At this stage, each bottle is carefully inspected by a machine to ensure that the amount of liquid is correct, and the caps are sealed properly. Bottles that do not meet the standards are removed from the production line. Speed and efficiency define the Coca-Cola bottling and capping process. As bottles are neatly placed onto a conveyor belt, they are then sealed and the product is labeled. Before distribution, each bottle is stamped with the production date and batch code, either on the cap or the side of the container, ensuring all necessary information is visible. The drink is also packaged in cans and glass containers, with multiple production lines operating simultaneously. Glass bottles are primarily reused, undergoing a thorough cleaning process using chemicals and high-pressure water, fully restoring them. However, brand new bottles are also produced. Coca-Cola follows a recycling strategy, continually encouraging the use of reusable packaging. Quality control is crucial in Coca-Cola's production process. The company implements strict measures to ensure that every bottle meets high-quality standards. Tests are conducted at various stages of production to guarantee the product's consistency and quality. These tests include tasting the mixture to verify its flavor, carbonation, and appearance. Additionally, bottles are tested under pressure to ensure they can withstand carbonation. Beyond these checks, Coca-Cola follows rigorous sanitation and safety procedures. To protect both workers and the product's integrity, employees wear protective clothing and ensure that the production facilities remain clean and free from contamination. The production of Coca-Cola is a complex and carefully controlled process that ensures consistency and quality in every package. After passing quality control, the products undergo a thorough wash with powerful jets of water before being packed for shipment. Cans and bottles are arranged into compact forms or stored in containers. With pinpoint accuracy, mechanical arms expertly position the blocks in place to create large pallets. The blocks are then moved to the packing area, where they are neatly arranged and carefully wrapped to ensure smooth transportation. The finished product is shipped to stores and distributors all over the world, making Coca-Cola available everywhere. The production process of Coca-Cola can vary slightly depending on the region, as customer preferences may differ. To cater to these preferences, Coca-Cola adjusts its recipe to align with local tastes, ensuring that every customer enjoys the flavor they love most. However, the core ingredients remain unchanged, carefully selected and blended to give the drink its signature taste. In the early stages of production, these elements are combined in precise proportions to create the liquid that gives Coca-Cola its unique and unmistakable flavor. High fructose corn syrup, derived from cornstarch, is used as a sweetener in many carbonated beverages. Coca-Cola's distinctive dark brown color comes from caramel coloring, which is achieved by heating sugar to the point of caramelization. Each year, more than 660 million pounds of sugar and other sweeteners are used to meet global demand for the beverage. Caffeine is included to give a boost of energy, while phosphoric acid adds a subtle tartness that balances the sweetness of the high fructose corn syrup. A crucial component of large-scale Coca-Cola production is water. Each processing plant requires a significant amount of water to meet production needs. In Mexico alone, Coca-Cola uses more than 14.5 billion gallons of water annually to maintain operations. The combination of these elements creates a delightful experience that has made Coca-Cola a legendary global drink. What actions do you think Coca-Cola has taken to reduce its environmental impact? Recently, Coca-Cola has been implementing innovative, plastic-free packaging alternatives to conserve resources and reduce waste. In 2023, the company introduced the Light Pack Top, an original holder made from recyclable cardboard designed to store bottles and cans. This replaced traditional plastic packaging and helped reduce the company's plastic use by 220 short tons per year. Coca-Cola is also committed to promoting the recycling of plastic and aluminum packaging. Recycling signs and information are placed on plastic containers and street bins to raise awareness about waste separation. At recycling plants, used plastic bottles are collected, inspected, sorted, and transformed into new products. A large industrial machine grinds the bottles into small pieces, which are then cleaned and go through a complex compression process, turning them into fresh plastic containers for food. Coca-Cola has recently updated its product lineup to include healthier and more eco-friendly alternatives, with a focus on low-sugar beverages and social responsibility initiatives. The company has launched environmental projects, such as optimizing water usage and creating recyclable packaging. Today, Coca-Cola is one of the most well-known brands globally, present in over 200 countries, and offering a diverse range of products that cater to a wide variety of consumer preferences.